everyone, welcome to InsightsByRish. In today's video, I am going to implement a project of multitask learning with NLP. Multitask learning basically means that we use a single model for different purposes. So here, the different tasks that we are going to perform by using a single model are emotions, violence, and hate detection from text. So as you can see, here is the architecture of the project. So you have the data for task 1, task 2 and task 3 separately, and then you pass that data separately itself to the main common single model that will share the layers between all of them, like various LSTM, embedding, spooling and dropout layer. And then again a separate output will be generated for each task. So this is multitask learning, where you are having separate inputs and a separate output will be generated from them, but the model that will be trained on the different tasks will be a single common model which shares the layer between all the tasks. And here task 1, task 2 and task 3, as I said, is emotion detection, hate detection and violence detection. The first major task that we will be having here, that is our task 1, which will be emotions, and inside that emotions we will have 6 distinct labels like sadness, joy, love, anger, fear and surprise. Similarly, in the task 2 as well, we will be having 5 distinct labels inside the major task, which is violence. So here we will be having different labels that corresponds to violence. And then in our third task, which is hate detection from text, again we will be having 3 distinct labels there. So a single task will consist of a major label, which is emotion, violence and hate, and then inside that major label it will also be having sub labels. So while detection, what we are going to do is first we will detect the major label, and after detecting the major label, then we will detect its sub label. So this is what we are going to perform, and this project comes under multitask learning category. So starting with, I am using 3 different data sets here. The first one is emotions, where we have the tweet, or we can say the text, and then we have the label for emotion. As I already shown you, here we have 6 distinct labels inside the major label emotion. Then the second dataset that I am using is gender-based violence tweet classification. This dataset will help us for violence detection from text. And the third dataset that I am using here is hate speech and offensive language detection, which will help us to detect whether there was any hate speech or any offensive language used in the tweet or not. So these are the 3 different datasets that we will be training our model upon. Also, the model will be trained on all these tasks individually, like we won't combine all these datasets into one. They will be separated, they will be segregated throughout the project, and the output generated for them will also be segregated and not combined, because that's what the purpose of multitask learning is. So going back to the Google Colab, here I have loaded all the CSV files in the Google Colab environment and we are good to go. So starting with, the first task that we are going to perform here is loading the data. We will be loading all the data sets here. So let me just say loading the data. So starting with, first we will load the emotion CSV file, and let's name our data frame as emotion df. So here I will say pd.readcsv. And for this, first we require the library. So here I will import pandas as PD. Now here I will provide the path of emotion CSV file, and let's run that. So let me display it to you. Let's display the first 5 rows. So these are the first 5 rows. Right now we are not performing any kind of pre-processing task. Here we are just loading the data. After loading all the data sets, then we will go ahead for pre-processing the data. Now the next, we will load the violence data here. So I will say violence data frame, and here I will again say pd.readcsv, and here I will provide the path of violence CSV file, which is this. Let me paste it here and let's run that. Let me also display it. So this is our violence data frame, and the third most and the last data that we will be loading here is hate. So let's name it as hate_df, and we will say again pd.readcsv, and here I will provide the path of hate data file. So let's run that. and let me again display it. So we are done loading all the data sets here. First we loaded the emotion CSV file, then we loaded the violence CSV file, and then we loaded the hate CSV file. Now if you closely look at all these data frames, you can see that here we have lot of unwanted columns in all of these data frames. Like in the first emotion data frame, we have this unnamed 0, which we don't require. In the violence data frame, we again have this tweet ID, which we don't require. And in the third hate data frame, we just require this class and tweet column. All others are unwanted. So the next task that we are going to perform here is data preprocessing. Let's write here the second stage here is data preprocessing. So we'll start with dropping unwanted columns here. So dropping unwanted columns. So first we will drop from emotion data frame. So let me write emotion underscore df dot drop. And then here I have to provide the names of column that I don't want. So in emotion data frame, the column that we don't want is unnamed 0. So let's copy its name and let me paste it here. So inside the single quotes, I will paste its name, and here we have to say in place is equal to true in order to make this changes permanent. After that, the second data frame that we have is violence data frame. So here I will say violence df dot drop, and here again we have to specify the names of column that we want to drop. So in violence data frame, we don't require this tweet ID column. So let me copy its name, and here inside the single quotes I will paste it, and again I have to say in place is equal to true. And the last data frame that we have here is hate data frame, and here we have to drop. Now if you take the look at this hate data frame, here we just require 2 columns, and apart from these 2 columns, all others are unwanted ones. So rather than dropping the unwanted columns, which are many in number, we will just create a new data frame with the same name, and we will just include these 2 columns, tweet and class, into that. So here I will say instead of drop, I will create a new data frame with the same name, hate underscore df, and here I will say hate underscore df, and then I will provide the names of column that I want in this new data frame. So here I will say tweet, and then I will say class. Keep in mind that this hate data frame is the existing data frame that we had, and this hate underscore df is the new data frame with the same name. So this is about dropping the unwanted columns. Let's run that. Now let's visualize the data frames further. So let me just say emotion df, and then also violence df, and then hate data frame. So right now we only have 2 columns in all our data frames, that is, one is for text and second is for its corresponding label. So we have successfully deleted all the unwanted columns from all our 3 data frames. The next task that we have to do here is, if you see, the naming conventions of the column names are different. Like let me just say here emotion df dot columns, then violence df dot columns, and then hate data frame dot columns. So if you see, for the first data frame, the column names are text and label. For the second data frame, the columns are tweet and type, and for the third data frame, the columns are tweet and class. So here we have different naming conventions for the column, and this is what we don't require. We want that the columns from all the data frames should have same name because they are performing same task. Like in all the first columns of all these data frames, it holds a tweet, basically a text value, while in all the second column of all these data frames, we just have the label for that corresponding text. So we want that all these columns should have same name. So next thing that we are going to do here is renaming the columns. Now here we won't be renaming the first data frame, which is emotion df, because there we have appropriate column names, text and label. We are going to rename the remaining 2 data frames. So let's specify it, violence data frame. Here I will say rename, and here I will say columns. Now while renaming the columns, first we have to specify the previous name, which is tweet, and then the new name that we want to give. So we will change the column name from tweet to text, and the second column name that we want to change is type, and we will change it to label. And then we have to say in place is equal to true in order to make this changes permanent. Same thing we will again perform for height data frame. So here I will say height underscore df dot rename columns. Again we have to specify the old column names and the new column names. So here I will again say tweet, and we will change it to text, and then class we will change it to label, and then again in place is equal to true. Let's run that. Now after running this, let's rerun this code what we had here. We will run it again to check now the names of our columns. So now we are having same column names for all the data frames, and this is what we wanted. Now after doing this, the next thing that we want to do is we will check for null values. So let me just say here, checking for null values. So here I will say emotion df dot isNA dot sum. This will give us the count of null values from every column of emotion data frame. Same thing we will again repeat for violence. So violence data frame dot isNA dot sum, and again we'll repeat this for height data frame. So height df dot isNA dot sum. Let's run that. So in all these three data frames we don't have any null value, which is a good thing. So till here we have done all the data pre-processing. Now the next thing that we want to do here in the data pre-processing stage itself is we want to take equal number of instances from all these data frames. Let me explain you what I'm trying to say. So if you check the shape of all these data frames here, like emotion data frame dot shape, then violence data frame dot shape, and then height data frame dot shape. So you can see all these data frames are having equal number of columns, that is 2, but the number of rows are different for all these data frames. Like for the first data frame we are having 4,16,000 rows, for the second data frame we are having 39,000 rows, and for the last data frame we are having 24,000 rows. So this is what we don't want. We want that all these data frames should be equal in number. So let's say that we want to randomly extract 12k instances, or we can say 12,000 rows from all these data frames. So that's what we are going to do right now. We are going to extract 12,000 rows randomly from all these data frames. So let's say here taking, or you can say extracting 12,000 rows from each data set. So first we will extract 12,000 rows from emotion data frame. Now again, you cannot extract the first 12,000 rows or any random 12,000 rows. There must be a pattern to extract those 12,000 rows. And what's that? And that is, if you check the value counts here for all its labels, that is the number of instances you have for each label here. You can see, as I said previously, we have 6 distinct labels here, and for each label we are having a different number of instances. Like for the label 1 we have the most number of instances, which are 1,41,000. For label 0 we have second most highest number of instances, which is 1,21,000, and so on. So there must be some pattern for extracting those 12,000 rows. What we are going to do, we are going to extract 2,000 rows from each label. And by combining those 2,000 rows of all these labels, we will create a new emotion data frame that will consist of 12,000 rows. Because see, we are having 6 distinct labels here, and 2,000 rows from each label will contribute to 12,000 rows in total. And that is what we are going to do. So let's write the code for that. So here I will say e_df, which basically stands for emotion data frame. And right now it will be empty. So data frame. Now after this we will write a for loop. So for I in range. Now the range will depend on how many labels you have in your data frame. Now in this emotion data frame we have 6 labels, and hence the range will be 6. Then here I will create a subset, and I will say emotion data frame, where the emotion data frame label equals to I. That is for first iteration, the value of I will be 0, and here it will basically mean that all the instances from the emotion data frame that equals to the label 0. In the second iteration, the value of I will be 1, and it will mean that all the instances from the emotion data frame that equals the label 1. And after that, I will be extracting random 2000 samples from all of these labels. So here I will use the sample method, which is an inbuilt method, and n is the number of samples you want to extract, which is 2000, and then you will give random state, just because you don't want to extract the same row that you extracted previously. You want to extract different rows that you haven't extracted. Here you can give any value. I will say 42, and then I will append this subset in the e_df, which was an empty data frame. So here I will say pd.concat, and what I'm going to concat is firstly the e_df and then the subset. What this for loop will basically do is, initially this e_df will be an empty data frame. Then for the first iteration, the value of I will be 0. That is, firstly this code will extract all the instances where the label is 0, and then after extracting that, then out of that all instances where the label is 0, it will extract random 2000 instances. So that will be 2000 rows for the first label. Then in the second iteration, the value of I will be 1, and it will extract all the instances where the label is 1, and then out of that it will again extract random 2000 rows, and it will append all this data in this e_df. So let's run that. Let's check the shape of this. As you can see, it's 12,000. Now we will create a copy of this and store it again in the emotion data frame, the same name that we had initially. So emotion_df, and we will just create a copy of e_df here. Let's run that, and now we will again check this code that we had here for this new data frame. So now you can see we are having equal number of instances for all this labels. So this was only for the emotion data frame. The same thing we have to again perform for other two data frames as well. The next data frame here is violence. So let me just put a line here. Next data frame that we have is violence. Let me just display its value counts for each label. So here we are having highly imbalanced rows. That is, for the sexual violence we are having the highest number of instances, while for harmful traditional practice we are having very low number of instances. So it's not possible to extract equal number of rows from all these labels. We have to extract uneven rows for these labels. So what we are going to do is, we will include all the rows for harmful traditional practice, economic violence, emotional violence, because they are less in number. And even we will include all the rows for physical violence, which are 5,900. And then to make it 12,000 in total, we will include 4,998 rows from the first label, which is sexual violence. So let me just write it here. We just want 4,998 rows from the sexual violence label, and for other labels we will extract all rows as it is. So let's say here sexual violence, this will be a data frame, and here I will say violence data frame, then again violence data frame, whose label equals to that of sexual violence. That is, we are basically extracting all the instances whose label is sexual violence, and then we will take a sample of 4,998 rows out of that. So sample 4998, and then random state is equal to 42. And after extracting just the 4,998 rows for the sexual violence label, we will delete the label, or we will delete the instances for this label. So let me just say here violence data frame is equal to violence data frame whose label is not equal to sexual violence. So basically what we are trying to do is, first we are extracting random 4998 rows from the sexual violence label, and later what we are going to do is we will delete all the instances that will have this label, so that now in our violence data frame we will just have the instances for the remaining 4 labels, and then we will append this 4998 rows to that violence data frame. So let's run that. Right now if you see the shape of violence data frame, we just have 7002 rows, which is a combination of harmful traditional practice, economic violence, emotional violence, and physical violence. Right now we don't have any rows for sexual violence in this violence data frame. Now we are going to append it. So now I will say here violence data frame is equal to pd.concat, and here I will be concatenating the sexual violence, all the rows for that label, and then the available violence data frame. And then we will give the access as 0, as we are concatenating it on the basis of rows, and hence the access is 0. Let's run that. And now let's check the shape of violence data frame. So right now it's 12,000 and we just have 2 columns. Fine. So this was for violence data frame. The next and the last data frame that we have here is hate data frame. So let me again just put a line here. Now we will check the value counts for hate data frame. So here we have 3 distinct labels, and again we have drastically uneven rows for all the individual labels. For the label 1, that is for offensive speech, we are having the highest number of instances, whereas for the label 0, which is neither, we are having very less number of instances. So here we will be including all the instances for the label 0 as well as for the label 2, and then remaining number of rows that we require to make the number 12,000, that many number of rows we will be extracting for the label 1, and the remaining number of rows that we require in order to make the total 12,000 is 6,407. So when you add 6,407 rows of label 1, 4,163 rows of label 2, and 1,430 rows of label 0, in total it makes 12,000 rows. So here I will say offensive speech. Label 1 basically corresponds to offensive speech, and hence I'm making the data frame with that name. Then I will say hate data frame, then the hate data frame label that equals to the label 1, and then we will take a sample of 6,407 rows, and then we will say random state is 42. Now again, as we did previously, I will be deleting all the instances for this label 1. So here I will say hate data frame. So hate data frame whose label is not equal to 1. Let's run that, and let's check the shape of hate data frame now. So now the shape of hate data frame right now is 5,593, and that is a combination of all the instances for label 0 and all the instances for label 2. Right now this data frame don't have any instances for label 1. Now we are going to append it. That is, we are going to append the 6,407 instances. So here I will say hate underscore df is pd.concat. Here we are going to concatenate first the offensive speech, and then the hate data frame, and then we have to say access is equal to 0, as we are concatenating it on the basis of rows. Just a minute. Fine, let's run that. And now let's check the shape of hate data frame here. So now it consists of 12,000 rows. Now let's check the shape of all the data frames again. So emotion data frame dot shape, then violence data frame dot shape, and hate data frame dot shape. So now we are having 12,000 instances for all these data frames, and this is what we wanted to do. Now let me display these data frames to you, and let's see if you can spot something unusual there. So let me just say emotion data frame dot head. I will just display the first 3 rows, then violence, and then hate. So you might have spotted the unusual thing here, which is the indexes. So if you take the look at indexes of all these data frames, they are anyhow, they are random, because that's what we have done. We have extracted the random text from all the data frames, but while extracting this text randomly, we also have extracted the corresponding indexes, and hence all the index for all these rows are uneven and they are basically anyhow. So now we want to reset them. We want to reset them into a particular order, like starting from 0, 1, 2 and so on. So the next task that we are doing here inside the data pre-processing stage itself is resetting the indexes. So here I will say emotion data frame dot, I will make the use of reset index, which is the built-in method, and inside this we have to give 2 attributes. The first one being drop, that is dropping the existing indexes, so true, and then in place is equal to true, that is making these changes permanent. And this is the same thing that we want to repeat for all the other data frames as well. So let me just do it. So let's run that, and let's again display all these data frames. So emotion data frame, then violence data frame, and then hate data frame. Now all the indexes are in proper fashion, which means we have successfully set all the indexes. So this was the end of the stage 2 of the project, which was data pre-processing. Now moving ahead to the third stage of the video, or we can say the third stage of the project, which is label encoding. So let me just say here, label encoding. Now, why we require this label encoding? So for that, to find out the reason, let's take a look at the data frames. So for hate data frame, we have the label in numeric fashion, which is good. That's what we want. But for violence data frame, the labels are in categorical nature, like we have the string values here. And again for emotion data frame, we have the labels in numeric fashion. So for emotion data frame and for hate data frame, we don't require any label encoding. But for violence data frame, we do require label encoding, because here we have the labels in the categorical format and we want to convert them into numeric one. So here in label encoding, first we have to import the label encoder. So going back to the first cell where we will be importing all our libraries, here I will say from sklearn dot pre-processing import label encoder, and we will also import the warnings here because Google Colab gives us a lot of unwanted warnings, so we just want to ignore them. Let's run that. Now coming back to the label encoding part, here we will create an object, or we can say an instance of that module. So let's name that instance as label encoder, and in this instance we will load the label encoder actual module that we imported from the scikit-learn. So let me just say here label encoder, and we don't have to give any attributes inside this module, we just have to import it. And after importing it, we will directly use the fit_transform method to transform the values of violence data frame. So let me just say violence df, then its label, and here I will use the instance which is label encoder dot fit_transform method. So fit_transform method is actually a handy one because it does 2 different tasks in a single go, or we can say in one go, which is fitting the module and also transforming the values. And here we will again say, like, we want to transform the values that are present inside the label column of violence data frame. Let's run that, and let's again display this violence data frame. So now the labels are in numeric fashion, and this is what we wanted. Fine. You can even see the unique values from this label. So let me just say here violence df label and unique. This will display all the unique values from the labels. So these are the unique labels, or we can say unique values, that we have in the violence data frame. And the significance, like what significance this number holds, that I have already mentioned in the starting of this file. Like as you can see here in the violence, what is the significance of every label, that I have already mentioned. Now, after performing this label encoding, this was the third stage of our project. After doing this, we will be moving ahead to the next part of the project, which is the fourth stage, and that is stopwords removal. Now, we are actually moving into the proper NLP part, where we are going to perform stopwords removal, then the tokenization, and then we are going to build the model. So here, the fourth stage is stopwords removal. For stopwords removal, you can go ahead with two different libraries. You can either use NLTK here, which is Natural Language Toolkit, or you can go ahead with the Spacy library. But here I will be using the Natural Language Toolkit library, which is NLTK. So let's import that first. So here I will say import NLTK, and then we also have to import the stopwords. So here I will say from nltk.corpus import stopwords. Let's run that for now. So coming back to the stopwords removal cell. So first we have to download the set of stopwords and the set of punctuations that we have in our English language. So for that, here I will say nltk.download, and we have to download the set of stopwords. After this, we also have to download the set of punctuations here. So I have to say nltk.download. And here I will say punct, which basically stands for punctuations. Let's run that. Now after importing, or we can say after loading or after downloading the stopwords and the punctuations, we can further go ahead for the stopword removal process. If you want to see what are the stopwords present in the English language, you can even do that. First we will load the stopwords here, and then we will visualize them. So loading the stopwords. Here we will say stopwords, and here we will say set, then stopwords. This is the module that we have imported from the NLTK corpus, and words from English language. After that, you can just visualize the stopwords, which will display you all the stopwords that are present in the English language, at least what NLTK has. So these are all the stopwords that are present in this NLTK module, and it will compare the stopwords with what we have in our text, and wherever it will find this stopwords, it will remove them. So if you just check the length of this, so in total we have 179 stopwords for English language in the NLTK corpus. Now going ahead, we'll write the actual function to remove the stopwords here. So let me just write here stopwords removal function. So here we will say def remove stopwords. Here we will pass our text. Text basically means all the text columns from our data frames. Then we will say all words. This will basically hold all the individual words for the text. Let's say for the first part, we are passing the emotion data frame here, and from that emotion data frame, we are specifically passing the text column of the data frame here. Then in that first iteration, it will extract the first row, or we can say the first text from that emotion data frame, and it will be tokenized here, and all those tokenized words will be stored in this all underscore words list. So here we will say nltk dot word underscore tokenize, and in this we will pass the text. After that, we will say filtered words, which will be the words without stopwords, and here we will say word for word in all words if word dot lower not in stopwords. So what are we doing here? See, this stopwords is the list that consists of the set of stopwords that we have in English language, as I already shown you here. So whatever words that are tokenized here are present in this all words list. And further, what we are doing is we are comparing this words that are present in this all words with the stop words that are present in this stopwords list. So if anywhere we find any words in this all words list that matches to the words which is present in the stopwords list, we will remove it. That is, we will not include it. And all the remaining words that are not matching to the words that are present in the stop words, we will include it in the filtered words. So basically we are removing the stop words here. And then we will return the sentence. So we'll join it. Just a minute. So here we will join it by space and we'll say join filtered words. Because this filtered words will be in the tokenized format, like the individual words, we have to further join them to make a sentence out of that. So this is the function for stopword removal, and then now we will pass our data frames to this. So first here I will say emotion data frame, and from this we will specifically change or will specifically modify the text column. So here I will say emotion data frame text dot apply. So here we will be applying this remove stopwords function. The same thing you have to again repeat for other two data frames as well. So let me do it. Let's run that. Now let's display the data frame again. Let's confirm whether this stopwords removal has really happened or not. So let me just say here emotion data frame, and we will display the first 3 rows from it. Now if you try to compare this with the original emotion data frame that you had here initially before stopwords removal, you can find that in the row 1 and 2 you had the word I. Like you had the word I everywhere. Then you also had the word have. Now if you see here in the emotion data frame after stopwords removal, you can see that you don't have that I anywhere in the row 1 and 2, and also you don't have that word have in the row 2, which means the stopwords removal has actually happened. And the similar kind of differences we would also spot in the other 2 data frames. So we are done with stopwords removal. Now we will move ahead to the 5th stage of this project, which is tokenization and padding. So let me just write here 5th stage, which is tokenization and padding. So here we are going to perform 2 different tasks. First we are going to tokenize the data, and secondly we are going to perform padding, which is a very essential task in any kind of NLP projects. So for this we require the tokenizer module and also the pad sequences module, which we will be importing from the Keras. So let's go to the initial cell and import that. So here I will say from TensorFlow, Keras and preprocessing dot text, we will import tokenizer. So tokenizer, just the T should be capital here, and then we will also import the pad sequences here. So from TensorFlow dot Keras dot preprocessing dot sequence. From this we will import the pad sequences. So let's run that. So going back to the tokenization part, here we will load that tokenizer module. So let's create an instance of that tokenizer module here. Let's name it as tokenizer, and in this instance let's import the tokenizer module that we imported from the TensorFlow Keras. After importing or after loading this module, then we will say tokenizer dot fit on text. This is an inbuilt method, so fit on text, and here we will pass the text column from all the data frames. So here I will say pd dot concat, and what are we concatenating? We are concatenating the text column from all the 3 data frames. So here I will say first emotion data frame, text column from that. Secondly violence data frame, again the text column from that, and for the last hate data frame, again the text column from that. Let's run that. Now after running this, we will create individual tokenized sequences for all the data frames. So first we have emotion data frame. So here I will say emotion sequences, and here I will say tokenizer dot text to sequences. So basically it will generate the tokenized sequences for the individual text. So sequences, this is an inbuilt method, and here we will pass the text column from the emotion data frame. And the same thing we will again repeat for the remaining 2 data frames as well. So let me do it. Let's run that. Now let's try to see how these tokenized sequences are generated. So let me just display a random row from the emotion data frame to you. So I will say emotion data frame, then a random row, or we can say a random text. Let's say I want to display the text from row 2. So I will say location 2. And this is the text present on the second location of the emotion data frame. Fine. Now let's check what are the tokenized sequences for this. So here I will say emotion sequences for the second row, which is 2 to 3. Let's run that. As you can see, this is the tokenized data or the tokenized sequence that we have for the row that we had here. Like for field, the tokenized value is 5, for like the tokenized value is 6, and so on. So this was the tokenization part. Now we will move ahead to the padding part. Now why we require padding is, right now all the sentences will be different in length. Like in the first row we will be having a sentence with 10 words. In the second row we might have a sentence with 12 words. In the fifth row we will have a sentence with 20 words. Now why we require padding? Because now why we require padding? Because right now why we require padding? We require padding because right now the length of all the sentences is different. Like for the first row, the sentence might consist of just 5 words, but for the second row, the sentence might consist of 10 words. Then for the fifth row, the sentence might consist of 42 words. So right now, all the sentences are having different number of words, and this is what we don't want. We want that all the sentences should be equal in length, and hence we require padding. So here I will say max length. Max length basically specifies the length, or we can say the common length of all the sentences. So let's say max length is 50, which means all the sentences will have 50 words, not more than that, not less than that. Here we will start padding for all the 3 data frames. So we'll start with emotion data frame here. So emotion padded, the pad sequences, which is the module that we have imported from the TensorFlow Keras. Here we will pass the emotion sequences, which is the tokenized data for emotion text. Then max length, that is what should be the length of sentences in this emotion padding, and that is equal to max length that we have specified in the beginning of this cell, which is 50. And then we also have to give padding type, which is post. There are basically 2 types of padding, pre-padding and post-padding. Post-padding means the zeros, that is the padding zeros, are added after the last element. Like if the maximum length is 50 and if in our sentence we just have 10 words, then 40 new zeros will be added after the last word. And in the pre-padding, the zeros will be added in the beginning, like the 40 zeros will be added in the beginning, and after that we will have the 10 words. Fine. So here we are performing the post-padding, which means we are adding the zeros after the last element of the sentence. So similar kind of padding we are going to perform for the remaining 2 data frames as well. So let me do that. So let's run that. So the issue is hate sequences is not defined. Let me just check that. It's actually hate, and I have misspelled the H here. Let me make it right. Fine. So we are done with that. Now let's check the difference between the original sequence and the padded sequence. So let's check the emotion padded again for the row 2. So as you can see, initially you just had this many tokens, or we can say this many words. Now you have many zeros after that, which are the padded elements to make the entire sentence of 50 words. Fine. So this is how the padding is performed. And after performing padding, we also have to convert the labels of all the data frames into array format, basically NumPy array format. So let me just first import the NumPy library here. So going to the initial cell, here I will say import NumPy as NP. Now coming back to the cell, here we will convert the labels of all the data frames into NumPy array format. So let me just write here, generating labels in NumPy array format. So first we will have emotion labels. Here I will say np.array, and in this we will pass the labels of emotion data frames. So emotion data frame, and from this the label column. The same thing we will again perform for the remaining two data frames as well. So let me just do that. Let's run that. So we have successfully converted the labels into NumPy array format. So this was the fifth stage of our project, which was tokenization, padding, and also generating the labels in the NumPy array format. Now we will move ahead to the sixth stage of our video, which is actually we are going to define the model in that stage. So this stage is the core part of this project, which is model definition. Here we are going to define our model's architecture. Now in this model definition, first we have to prepare the separate inputs for each dataset. Like we have three datasets here: emotion, violence, and hate. So in this multi-learning model, we have to pass each inputs independently. So let's prepare the inputs first. So prepare separate inputs for each dataset. So first we have is the emotion input. In this emotion input, we will have the emotion padded. So emotion padded. So whatever padded sequence that we have in the emotion padded, just like that we are passing it to the emotion input. We aren't making any changes. So basically this padded sequences for all the data frames are our inputs. Similarly, in the violence input, we have the violence padded, and then in the hate input we have the hate padded. So these are our inputs that we will give to our model. Let's run that. Now we will have separate input layers for this model. So let me take you back to the architecture of this model. So as you can see here, task 1 data, task 2 data, and task 3 data is supplied to the model individually, and again the individual outputs are generated. Just the core layers of the model, which are LSTM, embedding, spooling, and dropout, these layers are common between all of the tasks. Remaining the input and output layers are segregated. So this is what we want to generate. This is what we want to perform. We want to create a separate input layer for all the tasks. So going back to that part, here we will say defining multiple input layers for each task. So here I will say emotion input layer. Now for this we require the Keras module, and hence first we will import that module. So going back to the initial cell, here I will say from TensorFlow import Keras. So from TensorFlow import Keras. Let's run that. Now going back to the input layer part, here we will load the input layer from the Keras. So I will say keras.layers.input, and in this we have to specify the shape, basically the input shape. Now the input shape for all the layers is 50 because that's what the max length of our data is. We have padded the data and we have made them to a length of 50 by default, and all of them. So the input shape is length for all the data, and then we have to give the name to this layer. So let the name be input layer itself, basically the emotion input. So we have to perform the same thing for the remaining two tasks, that is violence and hate as well. So let me do it. So we are done with that. Let's run it. So these are our individual input layer for our individual task. Now we will start building the shared layers. So the core layers of the model, which are the embedding layer, LSTM layer, this will be shared among all these tasks. So let's build them. So I will say use a shared embedding layer. So here we'll say embedding layer. And here again we will load this embedding layer from the keras. So I will say keras dot layers dot embedding. Here we have to specify the input dimension, and this input dimension is the data, the tokenized data without padding. And as I said previously, it will vary for all the text, and that's what we are doing here. Here we'll say length tokenizer, in which we loaded our tokenized data, and here I will say word index. So it will extract the varied length of all the text automatically. We don't have to give anything manually here. +1. Now why +1? Because whatever the length of words will be, let's say in the first text we are having 5 words, so the index will start from 0. So 0, 1, 2, 3, 4, but actually the length of that text is 5. So 4 + 1, 5, and hence we are specifying +1 here. And then we have to specify the output dimension. Now what should be the output dimension? So you can give any value here, 128, 364, 562, any value here. I will keep it to 128. That is the generated embedding layer for every data should mandatorily be of size 128. So let's run that. This basically means that each input will be represented using a vector of 128 dimension. Now that we have generated an embedding layer, we will apply this single layer on all the different tasks. So first, let me just say here, apply the embedding layer to each input. Here I will say emotion embedding. In this emotion embedding, I will call this embedding layer, and I will pass the emotion input layer here in that embedding layer. For the second task, which is violence, I will name it as violence embedding, and here I will say embedding layer. I will again call that embedding layer here, and in this embedding layer I will be passing the violence input layer. That is, we have built a shared embedding layer that will be shared among all the tasks, and now we are specifically passing the different individual input layers to that single embedding layer. So here I will say hate embedding. Again I will call the embedding layer, and in this I will again pass the hate input layer. So let's run that. Now we will build a shared LSTM layer, that is the long short term memory. So let me just write it here, shared LSTM layer. So here I will say shared LSTM. This will be the name of layer. You can name it anything. And I will again take this LSTM layer from the keras itself. So keras dot layers dot LSTM. Now here we have to specify the number of neurons that will be present in our LSTM, or we can say the number of units that will be present in our LSTM. So let's say 64. You can give it anything, 32, 128, but it should be mediocre, not too less, not too high. And then return sequences is equal to true. Now you might know that return sequences are only true when there is one more LSTM layer after the current one, and right now you will see that we don't have any LSTM layer after the current one. So you might ask why the return sequences are true. This is because though on the forefront we don't have any LSTM layer after the current one, but in the background we will apply the same LSTM layer on different tasks. Like after performing the first task, the same LSTM layer will also be applied on the second task. After performing the second task, the same LSTM layer will also be applied on the third task. So here after the current one, though in the forefront we don't have one more layer, but in the background we are having the layers one after the other, and hence the return sequences are true. Let's run that. So as I said previously, we are applying these LSTM layers on the individual tasks. So first task is emotion, and let's name it as emotion LSTM. So we will call this shared LSTM layer, and in this shared LSTM we will pass the emotion embedding, which is the embedding layer for the current task. Then here I will say violence LSTM, and here again we will call the shared LSTM. And now we will pass the violence embedding here. So violence embedding. Then hate LSTM, and again we will call the shared LSTM layer here. And in this LSTM layer, now we will pass the hate embedding. So as you can see, we are applying the same layer on different tasks. This is what the concept of multitask learning is. Let's run that. Now, after running this, again we will create a shared pooling layer and the shared dropout layer as well. The dropout layer is used for regularization purpose. So here I will say shared global average pooling layer and dropout layer. Let's name it as shared pooling. Now again we will use keras here. So I will say keras dot layers dot global average pooling 1D, and we won't have any argument inside this. And then we will also build the dropout layer, which will be shared. So shared dropout. Here we will say keras dot layers dot dropout, and here we have to specify the dropout rate, which is 0.5, which means random 50% neurons will get switched off from each layer while the model training, so that the model don't overfit. Let's run that. Now what we are going to do is we are going to apply this pooling layer, that is the shared pooling layer, and also the shared dropout layer on all the individual LSTM layers that we have for all the tasks simultaneously. So let's do that. First I will say emotion features. Here first we will be applying the shared pooling, so shared pooling layer, and in that we will pass the emotion LSTM, that is the LSTM layer specifically built for emotions, and again we will apply the dropout layer over this. So shared dropout. So as you can see, we are simultaneously applying both these layers on the emotion LSTM. The same thing we will again repeat for the violence and hate as well. So let me just change the names. Let's run that. Now after doing this, we are done with sharing the layers. Now we will build the individual output layers, because the input layers and output layers will be individual. Only the core model layers will be shared among all the tasks. So here we will say first emotion output. Now output layers will be the dense one, like we will have a dense matrix there. So we'll say keras dot layers dot dense. Now how many neurons should we have in the output layers? So let me just say the same thing for the violence and hate as well. So violence output and hate output, and all of them will have the dense layers as their output layers. Now how many output units, or we can say how many neurons, should be present in the output layer of all this task? It will purely depend on how many unique labels we have in each of them. So let me explain what I mean. Let me just check the length of labels that are present in emotion DF and unique. Let's run that. So 6 unique labels are present in the emotion data frame. You can also see it here. I have specified it in the initial part of the file itself. So you can see these are the 6 distinct emotions that we have, which means we have 6 distinct labels here, and hence we should have 6 neurons in the output layer of the emotion. Fine. Now for violence, let me just repeat the same thing for violence as well, and also for hate. So here we will be having violence data frame, and here the hate data frame. Let's run that. For violence data frame, we are having 5 distinct labels, and for hate data frame, we are having 3 distinct labels, which means the neurons present in the output layer of the violence should be 5, and the neurons present in the output layer of the hate should be 3. So this output neurons will specifically depend on how many labels or how many unique labels you have in your data set. And after this, we have to specify the activation function. So let me just say here, activation. We will use softmax for all of these layers. And then we have to give name to these layers. So for the first layer, the name will be emotion output. For the second layer, the name will be violence output. And for the third layer, the name will be hate output. And we are applying this output layers on the features that we have built here. So whatever features that we have here, we are applying these output layers on them. So let me just specify that this emotion output layer is getting applied on the emotion features. Similarly, the violence output layer is getting applied on this violence features. So let me just specify it. And the hate output layer is getting applied on this hate features. Fine. So these are the output layers for the each task. Let's run that. So this was the total model architecture where we built the individual input and output layers and the shared core layers. Now we will compile the model. So let me just write here, compile the model with multiple inputs and outputs. So first we have to build the model, later we can compile it. So here I will say model is equal to, again we will import the models module from the keras itself. So keras dot models dot model, and first we will pass the inputs here. So what are our inputs? The inputs are nothing but the input layers for the individual task that we have here. Let me just scroll up. And as you can see, these are the input layers that we will be passing to our model individually, and these are the output layers that we will be passing to our model individually. Fine. So let's specify the inputs here. First is emotion input layer. Second is violence input layer. And third is hate input layer. So this is all about inputs. Now we will specify the outputs here. So outputs, and here we will specify the output layers. So for the first one is emotion output, just a minute. Then violence output, and then hate output. Fine. Now after specifying this input and output layers, we will go ahead for compiling the model. So model dot compile optimizer. Optimizer will be the Adam. Then loss function. Loss function will be the sparse categorical cross entropy for all of the tasks. Like for the first task, second task, and as well as for the third task, the loss function will remain same. So let's create a dictionary here, and here I will say emotion output. This names that we are giving it here in the dictionary should exactly match with the names that we have to the layers. Like for the emotion output layer, the name was emotion output itself, and hence we are giving the same name here while specifying the loss function as well. Whatever name that you are giving here in the name attribute of the layer, that same name you have to specify here while giving the loss function. And the loss function is sparse categorical cross entropy. Fine. Same thing I will repeat for the remaining two outputs as well, which is violence output, and the third is hate output. So all of this layers or all of this task will have the same loss function, which is sparse categorical cross entropy. Now after specifying the loss function, we also have to specify the metrics, that is based upon what this task should get evaluated. So all these tasks, we are going to evaluate them based upon their accuracy. So again, we will create a dictionary here, and again we will specify in the key value format. Same thing, again the names of the layers, which is emotion output, then violence output, and then hate output. Now all of these tasks are going to get evaluated based upon their accuracy. So I will specify here accuracy, and this will remain same for the remaining 2 tasks as well. Let's run that. Now after running this, you can check your model summary. So let me just say here model.summary. Let's run that. And as you can see, this is your model's total summary. It will show you how many input layers you have, how many core layers you have, and how many output layers you have. So as you can see, here we have input layer for all the tasks individually, which has the input shape of 50. Then we have the embedding layer here, a single embedding layer, because that will be shared among all the tasks, and that has input shape of 50 and the output shape of 128. Then we again have the LSTM layer, which will be having the input shape 50, and we have 64 units here. Then we have the shared global pooling layer here, which again has 64 units, and then we have the dropout layer, which has again 64 units, and the dropout rate is 0.5. And then we have the output layers individually for all the tasks, that consist of output neurons depending upon how many unique labels they have. For emotion it is 6, for violence it is 5, and for hate it is 3. So this is the summary of the model that you built. Now let's try to train it, or let's try to fit it. So let's write here training the model with separate inputs, because we are passing the inputs to train our model separately. So here I will say model.fit, and in this method first I will pass x. X will contain all our inputs. So again in the dictionary format, first we have to say here emotion input, and the value for this emotion input is again emotion input itself. Then violence input, so violence input, and the value for it is violence input. And then the last task, which is hate input, the value for it is again hate input. Fine. Now these are all the inputs to your fitting method. You also have to specify the labels for them. So here I will say y is equal to emotion output, and the labels are emotion labels. These are the labels that we generated by converting them into the NumPy array format. And then violence output, the labels here are violence labels. And then the last task, which is hate, so hate output, and the labels here are hate labels. So these are your input data and then your labels. Now you have to specify the number of epochs. You can give it anything. I will keep it to 10. Always start with less number of epochs. I will start with 10. And then I will also specify the batch size, which means the data won't be passed individually. The data will get passed in some batch, and that batch size is 4, which means for every iteration simultaneously 4 data items will be passed. So this is the model.fit method. Fine. Let's run that now. So as you can see, the training process has started and it will take a lot of time. So here you will see it is showing you the accuracy for emotion, then you have the accuracy for hate, and then you have the accuracy for violence. In the first epoch, you might feel that the accuracy is low, that is just 16% for emotion, 54% for hate, and then 63% for violence. But as soon as you start moving ahead, like in terms of epochs, this accuracy drastically increases. So as you can see, in the second epoch, the emotion output accuracy drastically increased to 82% from what we had in the first epoch was very less, 23%. So this is what happens, and as you inch closer towards the 10th epoch, it increases to more than 90%. Now the training process has been completed, and as you can see, at the end of 10th epoch, the emotion output accuracy is about 98%, the hate output accuracy is about 93%, and the violence output accuracy is about 99%, which is quite good. Now after training this model, we will go ahead with the predictions and evaluations. So moving ahead to the 7th stage of this project, which is prediction and evaluation. So first we have to make predictions based upon which we can later evaluate the model. So starting with, we will say here predictions, and then we will make use of model.predict method. Now in this as well, we want the predictions separately for each task. The predictions shouldn't be combined. So we will pass each inputs here separately. So first we will pass the input which is for task emotion. So emotion input in the dictionary format, of course. And then we will pass the emotion input here. After that we will have violence input, and then we will have here violence input, and then we have to pass the hate input. Just a minute. So let's say here hate input. Let's run that. Now after completion of this, the predictions for all these different tasks are stored in a single common variable, which is prediction. Let me try to display it to you. So if you see here, you can find 3 arrays. This is the first one, then you have the second one, and then you have this third one. So the first array shows the prediction of the first task, which is emotion. The second array shows the prediction for the second task, which is violence, and the third array shows the prediction for the third task, which is hate. Now we want to segregate them accordingly. So here I will say emotion spread. This will hold the predictions just for emotion task, and here we will make use of argmax method from NumPy, and this is because we have used softmax activation function in our output layer. That will just give us the probabilities. Later we have to extract the index at which we are having the maximum value. Like if you take the look at this first array, so you want to find that out of these 3 values, because this array, the last array that we have, is for the task hate, and in the hate, as you know, we have 3 distinct labels. One is offensive speech, one is hate speech, and third one is neither. So here we have the probabilities of all 3 of them, and at the index at which we are having the highest probability, that we have to extract, and we can only do that with the help of argmax method from the NumPy. So I will pass that prediction. Now as I said, for the emotion, the prediction for emotion task is the first array from these predictions. So I will pass the predictions at index 0. This index 0 will basically take all these elements from the first array, only from this first array. So this is for the emotion spread, and then we'll also give the axis as 1. Now violence spread. These are the predictions for violence, and here we will say np.argmax. Here we will say prediction. Now the predictions for violence are present in the second array, so we will say 1, and again the axis is equal to 1. And the last task, which is hate, so the predictions for it, we will say np.argmax, and the predictions for this hate are stored in the last array, which is present at the index 2nd, and again axis is equal to 1. So this will hold the predictions for individual tasks separately. Let's run that. Now this was the predictions. Now we will go ahead for evaluation using these predictions. So we will plot the confusion matrix, and for confusion matrix we require the confusion matrix module from metrics, and we also require Seaborn to plot it. So let's import that first. Going to the initial cell, here I will import Seaborn. So import Seaborn as SNS, and then from sklearn dot metrics I will import the confusion matrix. Let's run that. So going back to the evaluation part, Here I will write the function to plot the confusion matrix for all the three tasks separately. So def plot confusion matrix, and here we have to pass first true, that is the true labels, then we have to pass the predicted labels, and then we have to pass the title that we want to our confusion matrix and the labels. Why are we passing labels? If you just want to keep the numeric labels that we have right now, you can go ahead without putting the labels attribute here. But what I actually want to do is, while plotting the confusion matrix or while manually inferring the model, I want the actual label to be displayed, that is the categorical label. I want to display the categorical label and not just the numerical value, because in the first glance itself you cannot understand that what the numeric label actually represents, and hence I'm explicitly passing the labels here. So I will say here CF, which will hold the confusion matrix. Then I will pass here the true label, the pred labels. Then I will say normalize is equal to true, so that it will display us the data in the percentage format and not in the count format. Then I will say plt.figure. Here we have to give the figure size. So let the figure size be 7,6. This is purely based on trial and error basis. You can even change it. Then I will plot this. So we will make use of heat map here from C1. And here we will pass this confusion matrix. Then we will say n0 is equal to true, which basically means that we want to display the accuracy on top of the confusion matrix. And then cmap, which is basically the theme of confusion matrix, let's say blues. And then xtix label. This basically means that what labels we want to demonstrate or plot on the x-axis. So whatever labels that we are passing to this function should be displayed here. And even y-tick labels actually, even they should be equal to labels. So after plotting this confusion matrix, we will give the title to the confusion matrix. So plt.title, and whatever title that we are passing to this function, that we will give it here. Then we will say here plt.ylabel, that is the label for the data that we have on y-axis, and it is actual, which means the data on the y-axis demonstrates the actual values. And then plt.xlabel, so the x-axis data represents the predicted values, so prediction. Right now we don't have matplotlib here, so we have to import that as well. So going to the initial cell again, I will import the matplotlib library as well. So import matplotlib.pyplot as plt. Let's run that. Now going back to the confusion matrix part. After doing that, we are done with the function. We will come out of that function and we will create the text labels here. So the text labels should be in the order they are present uniquely in the data frame. By that what I mean is, let me just show it to you. For example, what I'm trying to say is, if you know the violence labels, the violence label are 0 to 4, but they are not in that ascending format. Let me just show you. If you say here violence data frame label dot unique, so they are in the uneven format. They are not in any particular ascending or descending format, like starting from 0 then going to 4, or starting from 4 then going towards 0. No, they are randomly. So whatever the value 4 holds, that should be given on its place while constructing the text labels. So starting with the emotion labels, first we have sadness, then we have joy, then we have love, then we have anger, then we have fear, then we have surprise. So these are the text labels for emotion. Next we have for violence. So violence labels text. So for the violence labels, the label 4 corresponds to sexual violence. So let's say here sexual violence. Now the label 1 corresponds to physical violence, so let's say that here. And the label 3 corresponds to emotional violence, while the label 0 corresponds to harmful traditional practice. So harmful, that is the violence caused due to harmful traditional practices. So traditional practice. and the last, that is the label 2, corresponds to economic violence. So economic violence. So these are the text labels for violence, and last we have hate. So hate labels text. Here first we have the label 1, which corresponds to offensive speech. So offensive speech. Then the label 2, which corresponds to neither, and the last label, which corresponds to hate speech. So these are the text labels that we built. Let's run this cell. Now let's plot the confusion matrices. So starting with, here we will call that function, which is plot confusion matrix. In this we will pass the true labels for emotion, which is emotion labels, then the predicted labels, which is emotion pred, then the title here should be confusion matrix for emotion, and then the labels, which are emotion labels text. Similarly, we will build the confusion matrix for the remaining 2 tasks as well. Let me do that. Let's run that. So as you can see, these are your confusion matrices, and on the diagonal you get the accuracy of the correct predictions, which means firstly you are having 99% accuracy for sadness, which means the true label is also sadness and the predicted label is also sadness. Similarly, you have 99% accuracy for joy, 100% for both love and anger, 98% for fear, and 99% for surprise. That is the accuracy for correct prediction. Same thing you can even see here in the violence confusion matrix, where you have 100% accuracy for all the 4 classes: physical, emotional, harmful, traditional, practice, and economic, and around 99% for sexual violence. And last, in confusion matrix for hate, you have 81% accuracy for offensive speech, 95% for neither, that is nor it is offensive speech, neither it is hate speech, and 98% for hate speech. So these are the confusion matrices. Now after plotting this confusion matrices and after evaluating our model, which is performing really very good, we will try to test our model on manual inputs. That is, we will try to give manually the inputs, and we will see how good the model is able to predict the major label and the sub label. So let me write here the 8th stage of the project, which is manual testing. So here let's write a function that will manually take an input and give us the corresponding output accordingly. So here I will say def classify text. This will be the function name. This function will take only the input text. Now in this function we will first pre-process the input data. So pre-process the input text. Here I will say input text cleaned, and this will basically the input text without any stop words. So I will say remove stop words input text. This is basically remove stop words. Now after that I will say here input sequence, and I will create a tokenized sequence of the input after removing the stop words. Whatever the procedures that we performed during this entire project, the same procedures we want to also apply here in this function for the new input. So here I will say tokenizer dot text to sequences, and here I have to pass this cleaned input text. After this, here we will have input padded, then we will pad the tokenized sequence. So here we will call the pad sequence model. Then we will pass the input sequence here. Then we'll give the max length, which is equal to max length, and then we have to say the padding, which is post padding. After this we will make the predictions. So let me just write it predictions, and the code for prediction will remain exactly same what we had here. Let me just copy it from here. So let's paste it here, and just the difference is On the place of emotion input, we will have the emotion padded. On the place of violence input, we will have violence padded. And on the hate input, we will have hate padded. After that, we will again extract the predictions for each task. What we did earlier, let me again copy it from there. So I will just copy this code and paste it here in this function. Let me just arrange its indentation. Now, after doing that, first we will determine the major label, that is either emotion, violence or hate. And after detecting the major label, then we will detect its sub-label. So here we will say determine major label. Inside this, I will say major labels. We have to specify explicitly what these major labels are, and they are nothing but emotion, violence and hate. Now we will choose our major label depending upon the confidence score, or we can say the one which has the highest confidence value, because we definitely need some logic to choose the major label, and hence it will be our confidence score. So here I will say major label index numpy.argmax, whichever has the highest confidence score, that we will select. So np.max predictions at 0, then np.max predictions 1, and then np.max predictions at 2. After that, here we will decide the major label. So I will say here major label, and here I will call this list of major labels, and I will extract the major label that is present on the index that we are extracting here. Now, after determining the major label, we have to determine the sub labels here. So to determine the sub labels, let me just say here determine sub labels, and before determining that, let me just add a s here in the predictions. Fine. After doing that, to determine the sub labels, here what I will do is we first have to manually give the sub labels. So whatever we had here while plotting the confusion matrix, so we'll just copy it from there, all these labels, and we will paste it here. And just let me just give it the correct indentation. Fine. After doing that, now we have to just say if major label equals to emotion, then the sub label will be emotion labels text, the list in which we have all the sub labels, and emotion pred. It's major. Fine. Similarly, we will do it for violence. So elif major label is equal to violence, then we will say sub label is equal to emotion labels text for violence pred, and then we will have else. In this else, we will just say sub label equals to, also it's not emotion labels text, it's violence labels text. This is the list that we have to pass here, and hate labels text is the list that we have to pass here. So here I will say violence, actually hate pred, and then we just have to return the major label and sub label. Let's run this function. Now to display its output, we will try to display its output in a simple interactive front-end kind with the help of widgets that are made available to us by Google Collaboratory. So here I will just say import IPY widgets as widgets, and then from IPython.display I will import display. So let's run that. Then we will define a text widget and a placeholder. So here I will say input text widget. Here I will say widgets dot text, and first we will have here description. So the description here is input text that we want to enter, and then we have to give the placeholder that will be visible on the place of area where we want to enter the value. So placeholder is equal to enter your text. Let's run that. Then we will define a button that will classify for us. So define classify button. So here we will specify the button, and here we will say widgets dot button description. What label, or we can say what title that you want to display on the button, that you have to give it here. So description is classify. That is, the word classify will be shown on the button. Let's run that. Now we will define the output. So define an output area to display result. So here I will just say output is equal to widgets dot output. Let's run that, and let's write a function to handle the event. So here I will say function to handle event. So I will say def on button, that this function will be activated on clicking on that button, and here we will say b. So I will just give this name as on button click, and in this function I will say with output dot clear output, because we want to clear the previous output here. So clear output, this will be used to clear the previous output. After that we will say here input text. Here we want to give the input text. So we'll say input text underscore widget dot value. Then we will say here major label and sub label classify text. This is where we are calling the classify text function. So classify text, the function that we wrote, this function of classify text, we are calling it here because it is returning two values. The function is returning as the major label and the sub label, and we are loading that returned values here in the same variables. Here we will pass the input text, and then we will print the major label, which is major label, and then we will also print the sub label. So sub label, and after that we will also attach the button here. So attach the button at bottom. Here we will say button, then on click, and here we will pass this function of on button click. Let's run that, and then here we will say display the input text widget, then the button, and then the output. Let's run that. We got some error here, which is only integer scalar arrays can be converted to scalar index, and after checking where we went wrong, I came across this. So in the function of classified text, instead of this emotion padded or violence padded, you have to just pass this input padded. So let me just pass it here everywhere. And also one more change is that it's predictions, so we missed a s here. So everywhere, let me add this. And after that, also the predictions that we want to extract are only present at the first index. So here I will say 0, similarly here, and also here. Now let's run everything again, and here I will input the text as I am afraid, and let's run that. Now after clicking on classify, as you can see, it's showing the major label as emotion and the sub label as fear. Similarly, let me change the text here from I am afraid to are you crazy. Now if I put this text and I click on classify, it's showing me violence and harmful traditional practice. So this is how you can input different sentences here, and once you click on classify, it will give you the output accordingly. You can fine tune this model according to your requirements. I have this code file on my GitHub. I will provide this GitHub repository in the description box. Do check that. And I will also provide the links for all the datasets. So that's it for the video. Thanks for watching.